Hello students, welcome to the next module. Today we are going to discuss question number 26 of exercise 5.1 where a function has been given as k cos x upon pi minus 2x at x not equal to pi by 2 and it is 3 at x is equal to pi by 2. We are given that the function is continuous at x is equal to pi by 2, hence we have to find out the value of this constant, right? Remember, these questions are important from examination point of view. So first of all, you need to remember the condition of continuity. That is, the left hand limit is equal to the right hand limit is equal to value of the function at x is equal to pi by 2. Likewise, limit x tends to pi by 2. X not equal to pi by 2 means either x is greater than pi by 2 or it is lesser than pi by 2. So if we are considering the left hand limit, it is limit x tends to pi by 2 negative fx is equal to limit x tends to pi by 2 positive fx is equal to f at x is equal to pi by 2, right? This is what the condition of continuity states. Now, the function here for left hand limit and the right hand limit will be the same. That is k cos x upon pi minus 2x. So let's find out the left hand limit. We have limit x tends to pi by 2 negative. The function is k cos x upon pi minus 2x. Right? So whenever a trigonometric ratio is involved in any question of limits, we need to make this particular limit as 0. How can it be made as 0? Only with the help of substitution. So which type of substitution are we going to make use of? It will be, we can assume x as pi by 2 minus h. Right? So if I say that x is approaching towards pi by 2, so h is approaching towards 0. As x approaches pi by 2, h approaches 0. So here we can replace, we have limit h tends to 0, k cos of pi by 2 minus h upon pi minus 2 pi by 2 minus h. Right? So this is k sin of h upon pi minus pi plus 2h, right? And this is limit h tends to 0. Okay, so we have this and this gets cancelled, right? So final expression is k sin h upon 2h limit h tends to and 0. Taking 1 by 2 outside, we have limit h tends to 0, k sin of h upon h. Since k is constant, we can also take this k outside, so it's k by 2, limit h tends to 0, sin of h upon h. And we have done this particular identity in case of matrices, that when limit x tends to 0, sin x upon x is always equal to 1. So our final result is k by 2 into 1, which is k by 2. So that is our left hand limit, right? Similarly, we can solve for the right hand limit. So let's see what do we get. See, for pi greater than x greater than pi by 2, then also the value of the function is the same. So let's solve it for that. So we have right hand limit, that is limit x tends to pi by 2 positive fx, and the function is limit x tends to pi by 2 positive k cos x upon pi minus 2x, right? So again we'll be making use of the substitution because a trigonometric ratio is involved here. What type of substitution? Now we'll be taking x as pi by 2 plus h, right? So this is limit as x tends towards pi by 2, h tends towards 0. So we have limit h tends to 0, k cos of pi by 2 plus h upon pi minus 2 pi by 2 plus h, right? So this is limit h tends to 0, k cos of pi by 2 plus h is minus sin h upon, this is pi minus of 2h, right? So this minus and this minus can get cancelled. So taking k outside and 2 outside, we have limit h tends to 0 sin h upon h, and this entire expression is equal to 1. So we have our right hand limit as k by 2, and we already know that the function is continuous, so it has to be that the left hand limit will be equal to the right hand limit. Likewise, now the value of the function at x is equal to pi by 2 is given to us as 3. Going by the condition, that is left hand limit is equal to right hand limit is equal to value of the function at x is equal to pi by 2. So what do we get? We get k by 2 is equal to 3, or k is equal to 6. This is how such questions have to be attempted. I hope it's very much clear to you all. Okay. With this, we move on to the next question. Next question is question number 27, which has to be done using the similar method, right? So we move on to question number 28. Here again, a function is given to us as kx plus 1 for x less than equal to 5, 3x minus 5 for x greater than 5 is continuous at x is equal to 5. Hence, we have to find out x. So going by the condition, first of all, left hand limit is equal to RHL is equal to value of the function at x is equal to 5. Why? Because the function is continuous. It is given that the function is continuous at x is equal to 5. So limit x tends to 5 negative fx is equal to limit x tends to 5 positive fx is equal to value of the function at x is equal to 5, right? So limit x tends to 5 negative, that is less than 5. The function is kx plus 1. So it's kx plus 1 is equal to limit x tends to 5 positive greater values. So that's 3x minus 5. That's a function. And f is equal to f at x is equal to 5 is the same as kx plus 1, right? So we can just omit that, right? Because already we have taken the left hand limits similar to the value of the function at x is equal to 5. So putting the values here, we have k into 5 plus 1 is equal to 3 into 5 minus 5. So that is 5k plus 1 is equal to 15 minus 5. This is 10. This is 5k plus 1. 5k transposing becomes 9. So k is equal to 9 by 5. And that is the value of the function when it is continuous. Sorry, that's the value of the constant value k when the function is continuous at x is equal to 5. Okay, moving on. Question number 29 can be done similarly.